If you are absent today, this is a video that will help kind of catch you up so that you're ready to go next time you're in math class with us. We're going to be on page 16 of the Unit 5 packet, the one with the ice cream cone on the front. And we're going to be doing a couple different things today. First thing we're going to do is what's called evaluate multi-step expressions. Kind of what we did, what you did remotely previously. We're going to take an expression here. We're going to substitute the variable and then find the value of the expression. The only difference between this and what we did previously was that there are more steps, a couple different, 2 or 3 steps that we'd have to take to evaluate these expressions. We're also going to learn how to write an expression using a variable, but we'll start with these first. So to evaluate any expression, the first thing we're going to do is we're going to write it out. Now this says 5t plus 4. When you have a number and a variable together, that's multiply. That means to multiply. So when I rewrite this, I'm actually going to put a dot in between the 5 and the t, making sure the t doesn't look too much like the addition sign, because I just want to remember that I need to multiply these numbers and not just put them next to each other. So in this case, t is 11. So the next step is to, instead of write t, I'm going to write the number 11. 5 times 11 plus 4. Now, when we think about order of operations, there's no parentheses, there's no exponents, but there is multiplication. Multiplication would come before addition. So we're going to do the multiplication first. 5 times 11 is 55, plus 4, I'm going to put some equal signs in there, plus 4 is 59. So we just evaluated the expression. We found the value of it if the variable t was 11. All right, let's try this one. This one can be a little bit tricky, because what you have here is a number next to a variable with an exponent. So there's 2 different things we have to do here. But the first thing I'm going to do is I'm going to rewrite the expression. So this means like 4 times x squared. So I'm going to write that out using a dot. 4 times x squared. Now in this case, x is going to be 3. So in my next step, wherever I see an x, I'm going to put a 3 instead. But I'm going to make sure to keep the exponent. So what we have here is 4 times 3 squared. The next thing I'm going to do is kind of go through the cheer. There's no parentheses, powers and roots. Well, there is a power. There is an exponent. So I'm going to do this first. I'm going to squiggle the 3 squared. Now 3 squared means 3 times 3, which is 9. So this would be 4 times 9. Now I'll just do the multiplication. 4 times 9 would be 36. So again, the only difference between this and what we've done previously is we're now doing 2 steps in the expression instead of just 1. All right, the last one here on this row, we have 10 times a plus 7. So I'm going to rewrite the expression, making sure to put a dot in between the 10 and the a because that's multiplying. We've got to remember that's multiplication, plus 7. Now in this case, a is 1/5. A is 1/5. So we're going to do 10 times 1/5 plus 7. Now we have to do order of operations. There's no parentheses, there's no powers and roots. Multiplication and division, so we're going to do the multiplication first. Now when I multiply this fraction, I'm going to make 10 a fraction as well, because you can multiply a whole number by a fraction, but it's a lot easier to look at when you have 2 fractions like that. So I'm going to multiply first. But here's the thing. If you look carefully at this, if you look diagonally, when you multiply fractions, you can always simplify. Well, you can simplify if you can. You can't always simplify, but we're going to check for simplifying. 10 and 5, we can divide them both by 5. 10 divided by 5 is 2. 5 divided by 5 is 1. And then we'll multiply. 2 times 1 is 2. 1 times 1 is 1 plus 7. Now, at this stage here, we can't really add these together because that's a fraction, that's a whole number. So we're going to change this to a whole number. 2 divided by 1 is 2, plus 7 is 9. So again, that one was a little tricky because you had a fraction in there. But the same rules that we've been working with all year with fractions apply here as well. So you can look for simplifying, and then we would change that into a whole number in this case, or even a mixed number if it was like something like 5/2 or something like that, or 5/3. But we got a whole number here, which is nice. All right, so at this point, we're going to try a couple more of these. If you want to try some of these on your own, or if you want to kind of do them ahead of me while I'm working, you can, and then check your answers against mine if you decide to do some of these on your own. So 2 times d minus 5, I'm going to write that out with a dot. Now, above here, this is where we're going to find the values of these numbers. D is 12, G is 2, E is 4. So in these 6 problems, anytime we see D, G, or E, that's the value of those variables. So my next step here is to write 2 times D is going to be 12. So instead of D, we're going to put 12 minus 5. We'll do the cheer, parentheses, no, powers and roots, no. Multiplication and division, that comes first before subtraction. 2 times 12 would be 24. Bring down the minus 5. And then we just have to do 24 minus 5, which is 19. Nice. All right. Let's try this next one here. We got D here again, so D is still going to be 12 for this problem. Next, first step, I'm going to rewrite it. 50 minus 3 times D, or 3D, 3 times D. All right, 50 minus 3 times D is 12. So I'm going to put 12. All right, parentheses, no. Powers and roots, no. Multiplication and division, yeah, we got that first. We're going to do that first. Comes before subtraction. 3 times 12 would be 36. And then we'd subtract these. 50 minus 36 would be, if you didn't know it, you could always do it off to the side, but it would be 14. All right, so now this one's a little trickier. This one's a little trickier because it's got an exponent in it. Well, I forgot to circle the answer. However, we're going to kind of follow the same steps we've been taking. This is 9 times e squared. 9 times e squared. So I'm going to write that as 9 times e to the second power, or e squared. Now in this case, e is 4. If I can see that right here. E equals 4. So I'm going to do 9 times e is 4. Keep the exponent there. 4 squared. Parentheses, nope. Powers and roots, yep, we're going to do those first. 4 squared means 4 times 4, which is 16. 9 times 16. Now this one I might have to do off to the side, which is okay. 9 times 16, that's the only thing left to do. I'm going to put 16 on top, times 9. 9 times 6 is 54. 9 times 1 is 9, plus 5 is 14. So the answer to this one is 144. All right. Let's try the next row down here. Similar idea, just different numbers. So this time we have 2 variables, 5 times d minus 15 times e. First step, of course, we're going to rewrite it using dots. All right, the d is 12 and the e is 4. So 5 times d is 12 minus 15 times e, and e is 4. All right, no parentheses, no powers and roots. Multiplication from left to right, multiplication and division. There's multiplication here. We're going to do that first. 5 times 12 would be 60 minus 15 times 4. So again, we're going to do the multiplication first before subtraction. Now, 15 times 4, 15 times 2 is 30. So 15 times 4 would be double that, which would be 60 as well. So this is 60 minus 60, which would be 0. That happens. So we got 0 for that one, which is fine. No worries. That happens sometimes. Didn't expect that, though. All right, here we go. We got 7 times g to the third power, or g cubed, plus 6. First step, of course. We're going to rewrite it. So 7 times g cubed plus 6. All right, let's check out G. What's G? Because we haven't seen G yet. G would be 2. So whenever we see G, we're going to put a 2 for this particular problem. 7 times 2 cubed plus 6. Now, there's a couple different things we might have to do here. All right, what's the first thing? Parentheses, no parentheses. Powers and roots, we're going to do the powers first. 2 cubed, that means 2 times 2 times 2. 2 times 2 is 4, times 2 is 8. So it's going to be 7 times 8 plus 6. Next, multiplication would come before addition. We're going to do the multiplication first. 7 times 8 is 56 plus 6. Put equal signs here. And 56 plus 6, to wrap it up, would be 62. All right, last one on the page here. We got 3 times e squared plus 4 times e plus 3. So first step, you know it. It's rewrite it. It's rewrite it. So 3 times e squared plus 4 times e plus 3. All right, so e is 4. So whenever we see e, even if we see it twice, we're going to put 4 every time we see e for these problems. 3 times e is going to be 4, keep the exponent, plus 4 times 4 plus 3. Now we just do order of operations. Do the cheer, parentheses. Nope, powers and roots. Yep. 4 squared means 4 times 4, which is 16. So we have 3 times 16 plus 4 times 4 plus 3. Go back to the start. Parentheses. No. Powers and roots. No. Multiplication and division from left to right. We're going to start here. Start from the left. Might have to do that off to the side. 16 times 3. Oh, the lights went out. 16 times 3. I got 48. Let's turn the light back on. Okie dokes. Okie dokie. All right, so we got 48 plus 4 times 4. We're just going to do this one step at a time, just like we normally do. Parentheses, no. Powers and roots, no. Multiplication, yes. It's the only multiplication left. 4 times 4 is 16, of course. Bring everything else down. Then we just got to do some adding. I'm running out of room here, so I'm just going to kind of go right through this problem here. We'll do this left to right first. So 48 plus 16. 48 plus 16 would be 64 plus 3. This was a doozy. 67. Now this one's the last one here is a challenge. You don't have to do that one. You wouldn't have enough room to do it on this piece of paper, so it says to do it in your journal. What it is it's m times a times t times h minus, in parentheses, m plus a plus t times h. So that one's quite a challenge. That's why it's called a challenge. But this last one here, this was a good one. Again, you just want to do one thing at a time. You don't want to try to skip steps and try to do more than one thing at once. All right, so we're going to kind of change gears here and do a little bit of writing expressions with variables. So if you turn the page, what we're doing here is we're almost like translating. We're given a sentence or a phrase, and what we're going to do with that sentence or phrase is we're going to write a variable for that sentence or phrase, and then we're going to write an expression using that variable. So we'll do a few together, and then in the next remote lesson, you'll try some on your own. So here's the phrase we're working with. $8 more than Ryan earned. Well, the first thing we want to think is what number do we not know? What amount do we not know? Okay? And that's going to be our variable. Well, $8 more than Ryan earned. We don't know what Ryan earned. That's going to be the variable. So we're going to let D, this is called a let statement. We're going to write let D, D is going to be our variable for this one. Let D equal amount Ryan earned. Because this D has to equal a number. So amount Ryan earned, that's going to be a number. I'm not sure what that number is yet. but we're going to use that variable to help us write the expression. Now, after we write the variable, we're going to think about the math words. What kind of math words are in this? So when I see more than, I'm going to underline that. Actually, you know what? I'm going to underline it. Actually, no, I'm going to circle it. More than. That's our math word. More than would indicate addition or adding. So we want to show $8 more than what Ryan earned. So now we're going to write the expression. I'm going to start with my variable D. I like to start with the variable D. That's what Ryan earned. Our expression needs to show $8 more than what Ryan earned. Well, here's what Ryan earned plus 8. That's going to be $8 more. That's the expression, D plus 8. So we're just taking a sentence or a phrase and we're using it to write an expression. This expression means $8 more than what Ryan earned. That's a good one. Let's try a couple more. $10 less than the original price. Well, the first thing is to think, like, what amount do we not know? I'm actually going to put a question mark above that. I don't know the original price. I don't know it at all. That's a number, but it's a number I don't know. So we're going to use a variable to show that number for now. We're going to let, I don't know, P. Let's use the letter P. Instead of O. I wouldn't use O because it looks too much like a 0. So we're going to let P equal original price because it's the number we don't know. We're going to use a variable because we're not sure what the number is. That variable, that letter, is going to represent or stand for the number we don't know. $10 less than the original price. Well, here's the math word, less than. And when I think less than, I usually think subtraction. So $10 less than the original price. Well, when we write the expression, P is the original price. That's what I'm going to start with. I want to show $10 less than that. So here's the price, and I'm going to take away or subtract $10 from that price. That's $10 less than the price. So now we have an expression that means the same thing as this phrase we started with. And the let statement, again, just shows, like, what does this variable equal? The variable equals the original price. Now, you might be thinking, like, why doesn't the 10 go first? Well, if you did 10 minus P, that's like starting with $10 and then taking the price away from that. That wouldn't make too much sense. This expression shows, okay, we have the price, then we're going to find what's $10 less than that. What's $10 less than that? So that's why this one's a tricky one. People sometimes get confused about this one because they want to put the 10 first, but the price would actually go first, then you're subtracting the 10. All right, let's check this one out. 4 times the number of gallons. Well, first, what is the amount we don't know? We don't know the number of gallons. I'm going to put a little question mark above that. So we need a variable. I'm going to let, I don't know, G, sure. G equal number of gallons, because that's what we do not know. All right, let's try to write an expression for this. G is the number of gallons. What's the math word? Well, the math word's times. I'm going to put a dot above times. I would put the X, but I'm going to put the dot just because we're not going to use the X anymore because we have a variable here. We don't want to use the X for multiplication because we're using a variable, and the X looks too much like an X because it is an X. So we don't want to use that for multiplication anymore when we work with variables. So here's the number of gallons, and we want to show 4 times the number of gallons. There's 3 different ways to do this. 4 times the number of gallons, we could do it like that. 4 times G. When you have the variable and the number right next to each other, you want to put the number first, then the variable right after it. That shows multiplication. Or 4 times the number of gallons, 4 dot G. Or you could use parentheses for parentheses G. But what you can't do is this. I'll write it and then we'll cross it out. You cannot do this. We'll do one of these things. You can't do that. We do not want the X in there because it looks too much like an X, like a variable X instead of multiplication. So So there's three different ways to write multiplication. Either any one of those would work. All right, this one's different. Half as many miles as Taylor ran. Half as many miles as Taylor ran. All right, well, what do we not know? We don't know how many miles Taylor ran. So that's going to be like, I'm going to kind of put this in a bracket here. This is what we don't know. That's what we're going to write our variable for. We're going to let, I don't know, M could be anything. Could be any lowercase letter besides O probably. Or a non-cursive L. We're going to let M equal miles Taylor ran. Now this one's a little tricky because you see this word half. That's actually the math word. Half means we're going to divide by 2. If to find half of something, you take that something and you divide it by 2. So you might expect to see like the fraction 1/2 here, but to find half, you can write it like this. There's a couple different ways. M divided by 2, that would find half of M, half as many miles as Taylor ran. Or you can do M, the number of miles Taylor ran, divided by 2 like a fraction like that. Whoop, probably can't see that. These are two different ways. Notice, the M would go first. We want to find half as many miles as Taylor ran. The M would go first. All right, so we're going to just do a couple more of these, and then in the next remote video, you'll practice this skill a little bit more. But I just wanted to show you, these are called one-step. These are like one-step expressions because you're just doing one thing to it, like you're adding 8, or you're subtracting 10, or you're multiplying by 4, or you're dividing by 2. The next couple we're going to look at are called two-step expressions, and you'll see why in a second. So if you go to the next page, we're going to do a couple of these. Let's see how they go. So you'll see why in a second we call them two-step expressions. I'm at the bottom of page 18, by the way. 5 less than 3 times the number of points. Well, we're going to start out the same way. What number do we not know? We don't know the number of points. So we're going to write a let statement to let us know what variable we're going to use. Let, I don't know, W, could be any lowercase letter, probably not O, or lowercase L, equal number of points. Let W equal number of points. This is 5 less than 3 times the number of points. I see 2 math words in here. Times, multiplication. I also see the word less, which is subtraction. Now, 5 less than 3 times the number of points. Now, we're going to kind of do this like order of operations. We're going to do the multiplication first and then the subtraction. So here are the number of points, W. How would we show 3 times the number of points? Well, when we do multiplication, the number usually goes first. So I'm going to do 3. I'm going to use the dot. 3 times W. So that's 3 times the number of points. Well, we want 5 less than that. So now we're going to subtract 5. So what this means is you have 3 times the number of points and then 5 less than that. Now I know if you try to do this one on your own, it would probably wind up looking like 5 minus 3 times W. But when it says 5 less, you want to subtract 5 from the amount. So that's why the minus 5 would go second. So whenever you see like 5 less or 3 less, you're going to have to remember like, oh, I have to subtract at the end and not put that number at the beginning. All right, we'll try one more of these today. We'll wrap this up, and then we'll practice this more in the next remote lesson. $3 more than 4 times the cost of a pretzel. Well, what do we not know? We don't know. Excuse me. Got too excited. We don't know the cost of the pretzel. So I'm going to show you some here. I'm going to use an L. But if you use an L, you don't want to use an L like that because that looks too much like a 1. So whenever you use an L, you want to use a cursive L. Looks like that. Now, I just picked L because I wanted to show you that. You didn't have to use L, but I just wanted to show you what that would look like if you decided to use an L as a variable, which is fine. But you just have to make it cursive, so it doesn't look like a 1. All right. This is a two-step one. How do we know? Well, we got times here, 4 times the cost of a pretzel, and we have $3 more, which is going to be adding. So again, we're going to start with the multiplication. We're going to kind of go in the order of operations here. 3 more than 4 times the cost of a pretzel. Well, here's the pretzel. 4 times more than that. That's 4 times the cost of the pretzel. Plus 3 would be $3 more. All right. So we'll kind of end there today. We did a couple of different things, but again, in the next video, we'll be working more with this skill. If you have any questions or you have anything that you're stuck on here, just send me a message, let me know, and I will get back to you as soon as I can. All right, have a great day. I'll see you soon. Bye-bye.